Okay, this is Florence, the mathematics tutor, and we want to look at a lesson on length of a tangent from an external point to a circle. So we have this circle over here. We have our tangent. We also have a point here. We have a radius. So we've connected. Now, if you study this carefully, the tangent makes an angle of 90 degrees at the point of contact with the circle. So here we can apply Pythagoras theorem. Let's name this side R, this side D, and let's name this side T. So by Pythagoras theorem, we know that to obtain our T is going to be the square root of the square of D minus the square of R. Now, from the given question on the board, we do not know R, neither do we know D. But fortunately for us, we've been given the point, the external point, which is negative 5, 8. And we've been given the equation of the circle. So first of all, this is what we can do. We can find the center. That's the point here. That's the first thing we need to do. Now, when you want to find the center, you equate the given equation to the general equation, which is giving us x squared plus y squared plus 2jx plus 2fy plus c is equal to 0. Now, so we know that the center is basically negative j, negative f. So we are going to equate this to the given equation. So let's pick this. We have 2g here. We equate it to the coefficient of x, which is our 4. Our g here is 4 on 2. But remember, we are going to have g is equal to 2. But here, the center is giving us negative g. So therefore, the final value of g will be g is equal to negative 2. Now let's come to the coefficient of y. We equate our 2f to the coefficient of y, which is negative 6. F will give us negative 6 on 2, where our f here is negative 3. But remember, the center is giving us negative f. So therefore, our final value for f is going to be f is equal to positive 3, because we negate this. So now we have the center. Our center is negative 2, positive 3. Then our point here, the external point, already giving us negative 5, 8. So now, this is what we need to do. We can use these 2 points to find the length of D. So let's look at length of D. So the length of D, remember, is giving us from coordinate geometry 1. It is the square root of change in x squared plus change in y squared, where we have square root of, now we have 2 values of x. So the change, so we have negative 5 minus 2 all to the power 2 plus our change in y, which will be 8 minus 3 all to the power 2. Now when we solve this, we are going to have square root of, let's look here, negative 5 minus 2 is basically negative 3. Negative 3 to the power 2 will give us 9. Let's come here. 8 minus 3 will give us 5. 5 to the power 2 is going to give us 25. I believe we are good with this. When now we obtain square root of 34. Okay, so now we have our D, which is equal to square root of 34. So we obtain one of the values. We are left with the R. Remember, R is giving us So now we are going, R is giving us the square root of J squared plus F squared minus C. Okay, so let's solve this one. Here, we know that our J, we had negative 2. So negative 2 to the power 2. Our F, we had positive 3. Positive 3 to the power 2. Minus our C. Remember, our C is the constant. So our C is the given constant here, which is 3. As we continue, negative 2 to the power 2 is 4. This will give us 9 minus 3. So we are going to have 4 plus 9, which is 13, minus 3, giving us the square root of 10. Okay, so now since we have our radius, our square root of 10, we also have the distance from the external point to the center. We can now find the length of the tangent. So by Pythagoras, that's by PT, we stated that the length of the tangent is equal to the difference of squares of the distance from the external point to the center and that of the radius. So our T, length of tangent, is square root of D squared. What is our D? Our D is square root of 34 all squared minus the R, which is the square root of 10 all squared. Let's see. So the square root implies 34 raised to the power 1 over 2. Multiplying the 2 here will give us 34. Then same for the square root of 10 is the same as 10 raised to the power 1 on 2. And we know that a power raised onto another power will multiply. So this will give us 10. Then as we continue, we'll have 34 minus 10, which will give us square root of 24. So therefore, the length of the tangent is going to be the square root of 24. If we want to simplify, that is using said, we are going to have 2 roots of 6 as the length, because square root of 24 can be written as the square root of 4 times the square root of 6, where we have 2 root 6. So therefore, the length of the tangent is 2 root 6. And this is Florence, the mathematics tutor. Thank you.